Hello everyone, my name is Darin Johnson. I'm part of the Aliaxis global marketing team. Aliaxis is a global leader in the manufacturing and distribution of advanced plastic piping systems, and we exist to bring solutions to the world's water challenges and accelerate the transition to clean energy. It's very clear that hydrogen has a central role in the clean energy transition and will be pivotal to helping us achieve our commitment of global net zero emissions by 2050. While hydrogen holds incredible promise in supporting and enabling a net zero energy system, it's still met with adoption challenges. So bringing together all stakeholders across the entire hydrogen value chain is going to be key to overcoming the major adoption barriers. This short session is intended to provide an introduction to hydrogen, introduce how Aliaxis is contributing to a hydrogen-ready future with our sustainable piping systems for green hydrogen plants, and we'll provide a high-level overview of the various applications within green hydrogen plants where plastic piping systems can be utilized. So we felt it important to start with the why question. Why hydrogen and why now? As a global community, we need to act urgently to tackle climate change and fight the effects of global warming. And renewable energy alone is not going to be enough to help us achieve net zero by 2050. It's going to require a partner. And this is where hydrogen enters the picture. More than any other substance on Earth, hydrogen holds tremendous potential to help us decarbonize the global economy. For one, it's extremely versatile. It can be used to store and transport energy, and it can act as a direct replacement to fossil fuels as a fuel itself. When it burns clean. The only combustion byproduct is water. But we also have to remember that not all hydrogen is created equal. There are several ways to produce it, which result in different carbon footprints. So the industry has come up with a color scheme for hydrogen to describe its production method, its source, and its carbon footprint. The majority of hydrogen production today is from what's called gray hydrogen, which uses natural gas in a process called steam methane reforming, where CO2 is emitted to the atmosphere. Gray hydrogen is used almost exclusively as a feedstock in oil refining and ammonia production for fertilizers, and it's responsible for a very large amount of global greenhouse gas emissions annually. So the prospect of growing the hydrogen economy by producing more gray hydrogen is not going to serve our decarbonization efforts. And this is why focus is primarily on two other colors of hydrogen. First, blue hydrogen, which is essentially produced the same way as gray hydrogen, but the majority of CO2 is captured and stored so it never enters the atmosphere. And then there's green hydrogen. And this has really been the focus of many end-use sectors in many countries. Green hydrogen is produced from renewable electricity like wind and solar and water in a process called water electrolysis. So we can actually split water with electricity into hydrogen gas and oxygen gas with virtually zero CO2 emissions. And this is where renewables and hydrogen form their partnership. So through what the industry calls the power to X ecosystem, we can now benefit from renewables even when they're not available by converting them into clean, green hydrogen via water electrolysis that can be used as a source of fuel, as a feedstock for industry, or as a source of power and heat in buildings, replacing fossil fuels, replacing gray hydrogen, and in turn helping us decarbonize a multitude of downstream sectors, many of which renewables alone have a hard time penetrating. So the power to X ecosystem is really the ambition and it's the long-term vision. But the reality today is that although we've done a lot of good work, we still have work to do. Hydrogen represents a modest fraction of the global energy mix, and only a small fraction of hydrogen stems from renewable sources. Furthermore, green hydrogen globally is more expensive than gray hydrogen, and in many scenarios, green is still too expensive to be a feasible replacement for gray hydrogen or as a replacement for fossil fuels directly. So to create this new ecosystem, to harness the power of hydrogen for long-term change, it's clear that, among other things, we need to reduce the green premium and we need to create the conditions for full adoption. So What do we need to do? Well, it's things like scaling up green production, building wind and solar capacity to support a green hydrogen economy, investing in research and innovation, developing new infrastructure networks, upgrading of existing infrastructure networks to deliver hydrogen to various end-use applications, and implementing the regulatory policies to remove adoption barriers. These are some of the key things. Easy for us to say, right? But we seem to be at a tipping point. Over 90 countries have net zero targets. Almost 40 countries have adopted a hydrogen strategy. And what's most promising is that project announcements and investments continue to increase on what almost seems to be a weekly basis. So to continue this momentum, we need all stakeholders across the entire value chain to come together to promote investments and to stimulate the rollout of clean, green hydrogen production and use. We believe manufacturers like Aliaxis are going to play an important role in the clean energy transition and in making green hydrogen globally competitive. So we understand and recognize that in a green hydrogen plant environment, the electrolysis stacks, the power supply, make up the majority of direct plant costs. So naturally, these are the focus areas for looking at more efficient ways of doing things, for looking for new innovations and new materials. But we cannot ignore the other cost contributors, notably the balance of plant. So what does that mean? Well, it's all of the auxiliary systems that are used to support electrolysis. So it's things like the cooling systems, which are used in several processes. It's processed water, water treatment, water feed, water recirculation. It's the electrolyte preparation, feed, and recirculation systems in alkaline plants. And it's the hydrogen collection and processing systems. The balance of plant can make up a significant portion of direct plant costs. So we also need to be looking in these areas for better ways of doing things, for new innovations, for new materials as well. An important part of the balance of plant is the piping systems used in the various applications and used to connect the different processes within a green hydrogen plant. In many applications at a green hydrogen plant, plastic piping systems can be a viable, economical, and sustainable alternative to the traditional metal piping systems that we're used to encountering in these environments without having to compromise performance, integrity, quality, or safety. Metals are sometimes chosen because they've been around longer, and that's just and it's something that we're just accustomed to using, which may lead us to overlook the benefits of engineered plastic alternatives, notably their superior corrosion resistance to in a wide range of environments, their excellent chemical resistance to a wide range of substances, their lightweight nature, their ease of installation and handling, which all contribute to their long-lasting service life. So what are the applications in a green hydrogen plant where plastic piping systems can be utilized? Well, there are a few of them which we're briefly going to touch on. So the first one is water treatment. Water is one of the main inputs in a green hydrogen plant. And before water enters the electrolysis stack, it has to be treated and demineralized to remove any impurities. The treatment method is going to depend on the raw water source, and it's going to depend on the water quality requirements of the specific electrolysis technology. Green hydrogen plants will often employ one or a combination of treatment technologies like reverse osmosis, like ion exchange, like electrodeionization. Plastic piping systems are quite established in these applications, and Aliaxis offers water treatment specific solutions, including our variety of flow control valves, so ball valves, butterfly valves, diaphragm valves, check valves in different materials, different configurations, and different control styles. We offer flow, conductivity, pH, ORP, sensors and monitors as part of our measurement and instrumentation solutions. And we even offer piping systems for clean in place systems and piping systems to safely handle ion exchange regeneration chemicals like hydrochloric acid, like sulfuric acid, like sodium hydroxide. For operations that are operating at elevated temperatures, a good example is water recirculation circuits coming from gas separators, where heat's picked up during electrolysis. It may be possible to use materials like CPVC, chlorinated polyvinyl chloride, which is capable of operating up to 95 degrees Celsius. So we may find that in many of these applications, there are a lot of different material and system choices. This is where a good manufacturer is going to be able to support you and provide guidance based on your project and technical requirements to make the optimal piping system choice for your specific application. At a minimum, a good manufacturer is going to be able to provide this support. Another important application related to alkaline water electrolysis is the electrolyte feed and recirculation system. So potassium hydroxide, KOH, typically in concentrations between 25 and 30%, is utilized in alkaline water electrolysis because it provides very good conductivity properties. Plastic piping systems like PVC and CPVC are ideal for safely handling potassium hydroxide solutions in various concentrations, pressures, and temperatures. Now, there are additional considerations with KOH and with other corrosive chemicals. What if the piping system is running over a critical area? What if part of the piping system is below grade? Some plastic piping system manufacturers will offer fail-safe double containment piping systems, essentially a pipe within a pipe, to ensure that in the unlikely event of a leak in a piping system that's conveying corrosive chemicals, the corrosive chemicals not going to be released to the surrounding environment. So again, many different options, considerations that need to be taken into account when selecting a piping system for a specific application, and a good manufacturer is going to be able to provide support in guiding you on selecting the right system for your application. The last application we want to mention is cooling water systems, which are required for several processes. So this could be cooling for dedicated rectifier units. This could be cooling for water feed and recirculation systems, cooling for electrolyte recirculation systems in alkaline plants, and cooling of the produced hydrogen gas as it goes through the purification, different stages of purification. A common cooling system that we may all know of more or less is called evaporative cooling, where a cooling water loop is utilized and it's delivered to the different processes, and it picks up heat through a heat exchanger from the different processes, and it then goes back to a cooling tower to dissipate heat, so another form of heat exchange. And then this process continually repeats as the cooling water loop picks up heat from the key processes and dissipates heat in the cooling tower or cooling towers. Aliaxis offers a number of different piping system solutions for cooling applications that are suitable for a wide variety of pressures and temperatures. Some of our systems can even operate down to minus 40 degrees Celsius and are also suitable for water glycol mixtures. So in closing, we'll say this. There's no one perfect piping system, and plastics are not suitable for all applications. But once properly selected and correctly designed and installed, Aliaxis piping systems are capable of providing years of trouble-free and have provided years of trouble-free, maintenance-free service. We said it a few times before. We have to say it again. A good manufacturer will be able to support you and provide guidance on selecting the best material and the best system for your specific application. And good manufacturers will also be able to provide guidance during all phases of a project, from design, installation, all the way to commissioning, operating, and maintaining a piping system. At Aliaxis, we believe we can contribute to making green hydrogen globally competitive, and we're dedicated to accelerating the clean energy transition with our sustainable piping systems for green hydrogen plants. So if you would like to learn more, please feel free to reach out to us. We'd be happy to chat. Thank you very much.